All right, in this one, questions 27 and 28, which apparently we had a little typo here. It should be a 27 and a 28. Um, we're going to solve these equations. These are radical equations. And here we're going to also look for extraneous solutions. Remember, anytime you have a even root, you need to be careful to look for extraneous solutions because an even power root cannot give you a negative answer. So for example, on this one, we have a radical here equaling x plus 1. So the smallest this radical could ever turn into is 0. So right off the bat, we know the values of x here have to be greater than or equal to -1, because -1 would get you 0 there. So this is your domain here. Your domain on this one, x would have to be greater than or equal to -1 for your final answer. So if you get anything smaller than that, then we know we have an extraneous solution. So on this one, this looks like a pretty straightforward question. Looks like we already have the radical by itself here. So it looks like we just need to square this side of the equation and square this side of the equation. When you square the square root, this comes out very nicely. The square root just goes away. These just wipe each other out. And over on the other side, looks like we have to do a little bit of FOIL. So it's x plus 1 times x plus 1. Remember, don't get in the trap. You're not allowed to distribute here. So you get x squared. Your outers and inners are both 1x's. So that gets you plus 2x. And then your last term, 1 times 1 gets you 1. And now here, this is where we really do the dance of joy, because we have an x squared on each side. So if you subtract, they cancel each other out. And now you're left with a very basic linear equation. So bring the 1 over, you get 8 equals to x. So x is equal to 4. And then checking our answers, since x is greater than -1, that would get you a positive 5 here. So this is going to work out quite nicely. It's going to get you 4 squared is going to get you 16, plus 9 is 25. Square root of 25 is 5, which obviously would equal 5. So that is a valid solution on this one. On 28, here we have multiple radicals. And anytime you have multiple radicals, you really want to get one radical by itself on one side and bring the other one to the other side. And this one looks relatively simple compared to some of the ones that we have done in this unit. Here we're going to bring this radical to the other side. I'd definitely pick this one because it's negative, and when we bring it to the other side, it's going to become positive. So over here, we're going to have 4th root of 4x equals the 4th root of 2x minus 16. And here, since we have a 4th root on each side, that means we could raise both sides of this to the 4th power. And these are going to cancel, which gets you 4x equals here. These cancel, and that gets you a 2x minus 16. And again, this one's extremely nice. Look at this guy. Here, if we subtract the 2x, we get 2x equals 16. So x equals 8. Okay. Now this one wasn't quite as easy to look at the original domain. Obviously, the smallest x could be here would be 0. And then here, a little trickier, you'd have to move the terms around. You get positive 16 divided by 8, by 2, which gets you 8. So let's do this a little simpler. Let's just go ahead and plug in. Let's just plug in our values here. So if we plug in an 8 here, this is 30. This is the 4th root of 32 minus, plug in here, we get 2 times 8, which is 16. 16 minus 16 looks like 16 minus 16 gets you 0. So this is the 4th root of 0. And this is supposed to equal 0. So the 4th root of 32, not quite sure what that is, but we do know what this here is. This is 0. So we have this number minus 0. Is that going to get you 0? It does not appear so. So this cannot work. So this has to be extraneous. Okay.